Hi, this is Mrs. Murdock, and today I'm going to walk you through how to do the Fruit Fly Lab, which is a virtual lab that we do in the genetics unit. So what you're going to do is you're going to get this packet on paper that talks about the life cycle of the fruit fly, which is a very, very handy organism to do genetics experiments with because they have a very short lifespan and they're easy to keep. They're small and you can feed them easily on mashed bananas and things like that. So you're going to have a link to a Flylab, which I'm going to show you in a second, and you're going to do 4 different crosses for me. And here they are. They're listed here, and I'm going to walk you through the first one. The first cross is you're going to cross a sepia-eyed male. Sepia is like a brown eye male with a wild-type female. And anytime they say wild-type, what they mean is what the organism looks like just naturally in the wild. So the wild-type flies have normal-shaped wings, and they actually have little red eyes. So now let me go to the actual Flylab here. There's the Flylab. All right. So the first cross, we're going to lead with a red-eyed female that's already a wild-type female. And here she is. She's already there, and she's ready to go. So we're going to select her for mating. See how her wings are normal, her eyes are red, her body is a normal brown color. We're going to select her for mating. Now we're going to select a male to go with her. So here we're going to go with Design Fly. You're going to click on that. And then we need sepia eyes for this male. So we go to Eye Color, and it gives us a choice. And you see that here's the sepia, which is kind of a dark brown color. And I'm going to click on that. There's the male that I want to breed with the female. So I'm going to select him. And now they're ready to mate. So I'm going to click on Mate Flies in the center. So up here are the parents that I just mated. Here's the wild-type female. And the male with sepia eyes, okay? And I selected them to mate. And here are their offspring. There's 2 types of offspring here, male and female, but they're all the same. Do you see how they all look the same? None of them have the sepia eyes that their father did. They're all red-eyed with normal wings. They look like the wild-type female. They all look like their mother, whether they're male or female. And you'll notice that there are numbers here. 512 females were born like this, and 473 males were born like this. And I actually have a bit of paper here, and I'm going to write down these numbers, which you are going to need to do as well as you're doing this lab. So 473, there we go. Okay, so then I'm going to go to the paper form, and I'm going to go down to where it tells me I can put the data in the first place. Here we go, right here. Cross number 1. All right. So cross number 1, you'll see, just like we just did, we crossed a sepia-eyed male with a pure breeding red-eyed female, right? There, we got that. And then what I'm going to say here is I'm going to write down the number of males with red eyes, because that was the only thing we got was red-eyed offspring. And the number was 473. And the number of females was 512. Okay. Now I'm going to go back to the lab, and I'm going to do I've done the parental generation and achieved the F1 generation. That's what these flies are. They're the F1 generation. I'm going to breed them with each other. So I'm going to select to mate and select to mate so that they will mate with each other and create the F2 generation. The F2 generation, just like Gregor Mendel found out, is where you find out some more interesting things. So look what happens when I select them to mate. There we go. So now they're all set. They are the offspring of that first breeding that I did, and I'm going to mate them, and you're going to find that the results are a little different from that F1. The F2 generation here, the offspring of that cross, we have females and males that are red-eyed, and we also have some females and males that are sepia-eyed, like the original sort of grandfather that they had 2 generations up. So once again, I'm going to write this down because I want to put that. Okay, so I have red-eyed 366 females, and I have sepia-eyed females. Also, the sepia-eyed females are 118. Okay, same with red-eyed males. I have 373, and sepia-eyed males, I have 129. So I just wrote those numbers down. Then I go over here to my lab, and I'm going to write those down. So again, I kept track very carefully of this. The red-eyed males there were 373 of them, and the sepia-eyed males, there were 129. The number of females with red eyes was 366, and the sepia-eyed females were 118. Okay, so now let's go down. One thing I am going to help you with is the Punnett squares that go with these problems. So kind of think about the fact that these are pretty close numbers here. There doesn't seem to be any sex linkage going on because we have the same number of female with red eyes as we have males, right? If there were no red-eyed males and lots of red-eyed females, we might think something's fishy there. If the sepia eye had come back up here, that might have been fishy, but it didn't. Okay, so that tells us it's probably not sex-linked. And you should also remember that, you should notice that there is a definite ratio of red eyes to sepia eyes up here. And kind of keep that in mind. We're going to go down to the Punnett squares. I'm going to help you do just for this first one, and the rest you'll do on your own. All right. So again, that first parental, right, the parental flies, right, the male, right, the original father was a purebred, right, a purebred sepia-eyed. The only gametes he could make, therefore the law of segregation, right, would have been little r gametes, and so we put them above the top of the Punnett square. So there's our male up there. Over here on the side, we have the female, right? And she was a pure wild type or red-eyed female. The only gamete she can make are big R and big R, right? So if you carry those across and down, the offspring are 100% genotype big R, little r, and red eyes, because red eyes would appear to be dominant here, okay? All right, now let's go over to the F1 cross. We took those flies and then we mated them with each other. So we took one of these babies and one of these babies, regardless of their gender. They were all the same genotype, and we mated them together. The male that we crossed had the same genotype as the female because, look, they're all the same babies, okay? The gametes that the male can make are big R and little r. Same with the gametes that the female can make. Big R or little r is all she can make, you see. So if you pull those down and across, you get a classic monohybrid result, right? Where you have two hybrids breeding in this F1 cross to give F2 babies that have a phenotypic ratio, right? Your phenotypic ratio in terms of red versus sepia is 3 to 1, isn't it? Of course it is. Yes. Now the genotypic ratio would be 1 to 2 to 1. But we're going to be mostly interested in phenotypic ratios here, meaning what they look like. The red versus sepia was 1, 2, 3 red versus 1 sepia, 3 to 1. Okay. So that's how you do a basic fly cross here, and that's how you're going to play it out. That's how it's going to play out in the Punnett squares. Now, there are other more complicated crosses here, but I will explain that in a different video, and I hope that was helpful.